Night settles over Boston with the quiet confidence of a city that thinks it has seen everything. Harvard glows in the dark like a fortress of knowledge, pretending it is not currently rewriting the rules of biology. In one lonely window, a light refuses to turn off. Inside sits David Sinclair. He moves like someone who has spent so much time studying aging that time stopped bothering him. There is this strange aura around him, the calm energy of a man who looks both 40 and immortal depending on the angle of the lamp. He stares at the camera during an interview and drops a sentence that should be whispered, not spoken. The first person to live to 150 may already be alive. And just like that, half of the scientific community gasps. The other half quietly Googles how to freeze themselves until further notice. But Sinclair is not trying to provoke. He is trying to warn us that biology has been trolling humanity for millennia. According to him, aging is not fate. It is not divine punishment. It is not the cosmic bill for existing. It is something much more mundane and much more dangerous. It is a loss of information, not in your DNA, but in the system that tells your DNA how to behave. The epigenome, the remote control of life. Imagine your body at 20. The remote works perfectly. Every button responds like it was designed by a team of Swiss engineers. Now imagine the same remote at 60. Buttons stick. Signals cross. The volume goes up when you try to change the channel. Welcome to aging. That is Sinclair's big idea. You do not get old because your hardware breaks. You get old because the software glitches. And suddenly, the idea of 150 years no longer sounds like science fiction. It sounds like a software update. But here is the twist. Sinclair is not selling dreams. He is not promising immortality or baby-skin billionaires doing yoga on Mars. He is making a statistical bet. The longest human life ever recorded is Jean Calment at 122 years. But mathematical models that examine resilience, recovery, and biological decay place the theoretical limit of human life somewhere between 120 and 150, which means Sinclair did not pull the number from a hat. He pulled it from data. Depending on your mood, that is either extremely exciting or deeply uncomfortable. Because if 150 is possible, the next question is terrifying. How do we get there? And that is what this video is really about. Today, we will uncover how Sinclair went from yeast experiments in a cramped MIT lab to reprogramming the eyes of blind mice. We will explore how a molecule called N-A-D became the hottest substance that is not illegal. We will see why gene therapy labs are quietly preparing for something that looks suspiciously like a biological reset button. We will examine the critics, the scandals, the million-dollar startup crashes, and the experiments that might change everything. Before we go any further, welcome to Crazy Science Stories. This is the channel where biology misbehaves, technology goes rogue, and the future shows up early just to watch us panic. If you enjoy learning things that sound illegal in 3 countries, take a moment to subscribe. You will need us in the coming chapters. To understand whether David Sinclair is a visionary, a troublemaker, or simply the scientist who dared to ask the most forbidden question in biology, we have to rewind. Not to Boston, not to Harvard, but to a small room filled with petri dishes, starving yeast, and a young researcher about to stumble on something strange. It is time to return to the moment the war on aging began. And yes, It all starts with hungry yeast. In the early 1990s, the halls of MIT buzzed with a strange kind of electricity. This was the era when genetics felt like a treasure map, and every lab drawer might hide a secret worth a Nobel Prize. In the middle of all this academic chaos, a young Australian researcher stepped into the scene with curious eyes and the energy of someone who believed the rules of biology were optional. That researcher was David Sinclair. He joined the lab of Leonard Guarente, a brilliant scientist with the calm intensity of a man who spent more time thinking about life than living it. From day one, something clicked. Sinclair was the kind of student who asked dangerous questions. Guarente was the kind of mentor who answered with even more dangerous ideas. The story goes that Sinclair once asked something close to this. What if we could slow down aging? Instead of laughing, Guarente basically said, "Come in, we will figure it out." Together, they explored a tiny genetic universe inside simple yeast cells. And one discovery changed everything. They found a group of genes called sirtuins. These genes seem to respond to stress and starvation by turning on survival pathways. The more the yeast struggled, the longer they lived. It was a biochemical plot twist. To make the idea simple, sirtuins are like the maintenance team of your cells. When they are active, the cell stays clean, repaired, and efficient. When they slow down, the whole system starts to look like Paris after 3 weeks without trash collection. Nothing catastrophic at first, but give it time, and things get messy. Sinclair was not selling fantasy. He was uncovering real biology. He published serious papers, presented real data, and slowly built a reputation as someone who pushed boundaries without losing scientific discipline. Even his critics admitted he had talent. Then came the moment every scientist secretly dreams about. A discovery that sparks an idea that becomes a company that becomes a headline. The world met Sirtuins, a startup built around the possibility that activating sirtuins could extend lifespan. Investors loved it. Scientists argued about it, and GlaxoSmithKline eventually bought it for $720 million. For a moment, Sinclair looked like the pioneer who might actually drag humanity one step closer to longer life. The kind of scientist who makes bold bets and then watches the universe blink first. But in science, no victory stays uncontested. Another researcher, Charles Brenner, began examining the early experiments behind sirtuin activation. He discovered flaws and artifacts in some of the original assays. Certain molecules thought to activate sirtuins were not doing what everyone believed. The results were more complicated and sometimes disappointing. Sinclair was not caught lying. He was caught in something far more common and far more painful. The biology fought back. Results contradicted one another. Methods clashed. And suddenly the longevity revolution felt less like a straight road and more like a maze. This is where you see the difference between a dreamer and a scientist. A dreamer ignores the data. A scientist adjusts. Sinclair chose the second path. You do not have to choose a side here. Maybe the early sirtuin hype was too loud. Maybe the criticism was too sharp. But one thing is true. This field is not a peaceful garden. It is a battlefield where every idea must survive experimental fire. It was not that Sinclair was wrong. It was that biology is a combat sport. Yet he did not stop. He did not slow down. He did not retreat from the fight. He did something much more interesting. He changed weapons. When Sinclair turned the page on sirtuins, He did not slow down. He simply followed the wires deeper into the machinery of life. What he found next looked small, unremarkable, and almost boring. It was a molecule every cell already used. A molecule so common that scientists barely noticed it. Its name was N-A-D. To Sinclair, N-A-D felt like discovering a hidden power line. It was everywhere. It was essential, and it was fading with age. Imagine it as the premium fuel of your body. At 20, you run like a Tesla fresh from the factory. At 60, you drive like a tired Clio that has survived 500,000 kilometers and several questionable mechanics. N-A-D is the spark that keeps your metabolism alive. Without it, your mitochondria choke. Your DNA struggles to repair itself. Your cells lose the ability to manage stress. This decline is one of the most reliable signatures of aging. The older you get, the lower your N-A-D levels fall. Sinclair asked the obvious question. If the fuel tank empties with age, what happens if we refill it? That is where N-A-D boosters enter the scene. Scientists began exploring molecules like N-A-D and NMN and a more pharmaceutical version known as MIB626. These compounds act as precursors. They are basically the ingredients your cells use to rebuild N-A-D from scratch. Human studies began slowly. Small groups, short durations, and cautious optimism. The results were clear. These molecules increased N-A-D levels. Some people saw better insulin sensitivity. Others showed improved muscle metabolism or endurance. It was promising, but not miraculous. This is where the humor sneaks in. N-A-D boosters are not the fountain of youth. They do not erase wrinkles or turn you into a Marvel character. They behave more like WD-40 for the inside of your cells. Things run a little smoother. The noise quiets down. The machinery feels less rusty. But science is rarely a straight line. The results in animals were mixed. Some studies showed improved health span. Others barely moved the needle. Extending lifespan remained elusive. No experiment could claim that boosting N-A-D alone added years to a mammal's life. Not even the enthusiastic mice volunteered for that kind of miracle. Then came the regulatory storm. The FDA stepped into the arena. At first, it blocked NMN from being sold as a supplement. The reason was simple. A pharmaceutical company was studying it as a drug. Suddenly, the internet exploded with panic. People accused regulators of stealing their youth. Influencers made dramatic videos about government conspiracies. Months passed. More data arrived. And in a surprising twist, the FDA reversed its decision. NMN became legal again as a supplement. It felt like watching a thriller where the villain becomes the hero because the script changed overnight. The field of longevity went wild. Through all of this, Sinclair remained steady. He never claimed N-A-D boosters were the answer. He framed them as one piece of a much larger puzzle. A way to support cellular health while bigger, bolder interventions took shape in the background. Because here is the truth. To Sinclair, N-A-D is not the destination. It is the fuel you need to reach the destination. The real revolution is still waiting behind the curtain. Not slowing aging, but pushing the biological clock backward. Not managing time, but bending it. And that brings us to the next chapter. Everything Sinclair had done so far pointed in one direction. Slow the decline. Delay the damage. Keep the remote control from jamming. But then came the discovery that changed the tone of the entire field. A discovery that did not just slow aging, it seemed to reach into the past. In 2020, Sinclair's team published a paper in Nature. It described an experiment using 3 of the 4 Yamanaka factors, known by the letters O, S and K. This technique partially reprogrammed the cells of mice without wiping their identity. What happened next sounded impossible when scientists first whispered it in conference hallways. Blind mice saw again, not metaphorically, literally. Their damaged retinal cells behaved as if someone had rolled back the clock. Imagine a 50-year-old cell waking up and remembering it was 20. Not dreaming it was 20, but actually recovering the molecular signature it once had. The effect was so dramatic that even seasoned researchers asked for the data twice. Now, let's explain how it works. Yamanaka factors are like master switches that can turn any adult cell back into a stem cell. It is the biological equivalent of factory reset press the button fully, and the cell forgets everything. Press it halfway and something magical happens. The cell keeps its identity but regains its youth. The best metaphor is simple. It is the reset button, but used gently so you do not erase the whole hard drive. A soft reboot of life itself, a reminder that the code of youth never disappears. It just gets buried under noise. This is why the study shook the field. Until then, aging seemed like a slow decay, something we could slow but not undo. Suddenly, the idea of reversing biological age moved from fiction to preclinical evidence. It was not perfect, it was not safe yet, but it was real. Scientists reacted with a mix of awe and fear. Awe because the implications were enormous. Fear because reprogramming cells is like handling dynamite with gloves made of curiosity. Push too far and the cells can lose control. The biggest risk is cancer. When cells forget who they are, they can become something they should not be. Sinclair was careful about this. He did not claim victory. He did not promise eternal youth. He presented the result the way a responsible scientist should. A breakthrough, yes, but a breakthrough surrounded by danger signs. The methods were complex. The long-term effects were unknown. The path from mice to humans was still long. To bring the discussion back to humans, the world looked at the TRIM study, a small trial where volunteers took a combination of growth hormone, DHEA, and metformin for 1 year. Their epigenetic clock moved backward by about 2.5 years. It was a tiny sample with no control group, but it showed that reversing age markers in humans might be possible. The key word is might. The results were exciting, but fragile. No one should put their mortgage on it. Still, something had changed. For the first time in history, scientists had data suggesting that human age is not a one-way street. The door was not wide open, but it had cracked enough to see a different future behind it. This is where we must stay balanced. Sinclair never claimed we can all reverse our age tomorrow. He claimed that biology is giving us hints and that ignoring them would be foolish. But biology does not evolve in a vacuum. Every discovery attracts attention, and attention attracts money. Because when someone shows even a small possibility of reversing time, the world does not react calmly. Investors arrive, startups emerge, entire industries realign, egos expand, and suddenly the quiet world of molecular biology starts to feel like Silicon Valley during a gold rush. As Sinclair's ideas spread, excitement grew, but so did the spotlight. And spotlights attract everything, including critics, journalists, and the occasional investor who confuses hope with math. Before long, the Wall Street Journal released investigations about conflicts of interest and financial entanglements in the longevity world. They questioned startups, patents, and whether Sinclair stood too close to companies that might benefit from his research. But here is the truth. Being a pioneer also means being a target. Anyone who steps into an untouched forest must deal with branches, stones, and the occasional angry bear. Sinclair pushed boundaries. Some people admired that. Others reacted the way academia often reacts to new ideas, with suspicion first and discussion later. Inside the scientific world, the debate grew louder. There was the team inspired by Sinclair, convinced the future of medicine is rejuvenation. There was the team shaped by Charles Brenner, cautious and deeply focused on biochemical precision. And of course, the mainstream camp, where skepticism is a survival instinct and enthusiasm is rationed like emergency rations. Together, they created the perfect triangle of scientific tension. Bold futurists on one side, careful biochemists on the other. And in the middle, a group of researchers who aged visibly every time they opened their email notifications. Longevity science may extend life one day, but it certainly does not extend the patience of the people who study it. Amid this tension, another topic emerged: biological age testing. Companies began offering ways to measure how old your body is at the molecular level. Sinclair co-founded Tally Health, aiming to give people a clearer picture of their epigenetic clocks. It was a clever idea, a useful tool, and also a spark for debate. Some scientists argued that these tests are impressive, but still imperfect. Epigenetic clocks predict trends well, but individual scores can vary. Others warned that the science is racing ahead of the regulation. And a few said the tools are fine, as long as people understand they measure probability, not prophecy. Through all the noise, Sinclair remained a singular figure. Part storyteller, part scientist, part explorer standing at the edge of a new continent. People follow him because he has the rare ability to make complex biology feel like a map that anyone can read. He is not a salesman. He is not a guru. He is the scientist who cuts through the jungle with a machete so that others can walk on a path. Even his critics admit this. They may argue with his optimism, but they respect the spark he brings. Because science needs people who question the obvious and aim for the impossible. And now, we reach the heart of the story. After all the studies, after all the debates, after all the hopes and warnings, what does the science actually say? Is 150 nothing more than a poetic dream? Or is it a possibility waiting to be tested? Now that we have walked through the science, the scandals, the breakthroughs and the failures, it is time to slow down and look at the truth with clear eyes. The facts are neither a miracle nor a disappointment. They are something much more interesting. Here is what the science truly supports. We can extend health span. Humans can stay healthier for longer and delay much of the cellular damage that defines aging. We can slow the decline. We can make old tissues behave like young ones in animals. And we finally see the first hints, tiny but real, that age reversal in humans might be possible someday. Now, the limits. No experiment has pushed a human past 120 in a verified way. No therapy today can guarantee more life than Jean Calment. Nothing so far has proven that humans can reach 150. That number lives in models, in equations, in possibility, not in reality. So the reasonable stance sits in the middle. Sinclair is not promising miracles. He is pointing toward a horizon that science has ignored for too long. His models are plausible. His ideas align with discoveries from labs all over the world, but they are not proven. Not yet. The door is half open, not fully unlocked. And that leaves us with the most important part of the story. The part where you and I must decide what this all means. Because Sinclair's work is not only about cells and molecules, it is about imagination. It is about the courage to ask questions that make people uncomfortable. It is about refusing to accept that aging is a law of nature simply because it has always felt that way. Maybe Sinclair exaggerates sometimes. Maybe he sees too far ahead. But if no one looks toward the impossible, how do we ever shift what is possible? So let me ask you directly. If the first human to live to 150 is already here, what does that change in the way you think about your own life? Would you want those extra decades? And what would you do with them? More time with the people you love, more adventures, more mistakes, more second chances. But here is the real question. Even if reaching 150 were possible, would it actually be a good idea? More wisdom, or just more time to repeat our mistakes on a limited planet with limited resources? Do you believe biology can bend this far? Is aging destiny, or a puzzle waiting for someone brave enough to solve it? And where do you stand on Sinclair's ideas? Vision, illusion, or the future showing up early? Maybe you feel hopeful. Maybe you feel skeptical. Both reactions are valid. But one thing is certain. The story is not finished. Not for Sinclair, not for biology, not for us. Because the true frontier of human life is not a number. It is a question. How far can a human really go when we stop assuming the limit is fixed? And now it is your turn to answer.